Hello everyone, welcome back to the channel. I hope you are doing great and continuing your DSA journey with consistency. So in this tutorial, we are going to solve this problem by Tony Point. So here an array is given to us and in first it is strictly increasing and then it may strictly decreasing. So we have to find the Bitonic point that is maximum element in an array. So our first concern is that what is Bitonic point? So you can imagine a mountain whose peak value is called Bitonic point if its left side is decreasing and its right side is also decreasing. So this is the Bitonic point. Let's take another scenario like we have multiple peak element. This is also a peak value. This is also a peak value. This is also a peak value. But we have to find the maximum value of the peak. So here the Bitonic point is this one. So in this problem, we have to find this maximum value whose left side is strictly decreasing and whose right side is strictly decreasing. So we have to find this Bitonic point. In this tutorial, we are going to solve this problem from brute force approach to optimal approach. So you can see that an array is given to us and the maximum value inside this array is 8 and whose left side is decreasing and whose right side is also decreasing. So we have to return this as an output. So simply traverse an array and find the maximum value. That maximum value is called the Bitonic point. So let's deep dive into the notebook and see the logic behind this problem from brute force approach to optimal approach. Here an array is given to us and we have to find the Bitonic point. So we have to traverse the whole array and find the maximum value. So here 8 is the maximum value. So we have to return this 8. There is another array given to us. We have to simply traverse the whole array and find the maximum value. So in this array, the maximum value is 45, whose left side is also strictly decreasing and whose right side is also decreasing. Because if any element is maximum, then whose left and right both are by default less than that. So both sides are strictly decreasing. So we have to simply traverse this whole array from index 0 till index n minus 1, and we have initialized one variable with the int min, that is Bitonic point. We have to compare that Bitonic point with every element of this array and update the maximum value inside the Bitonic point by traversing the whole array. Let's suppose our first value is index 0, that is 1. So 1 is greater than int min. So our Bitonic point is updated with 1 and our index is updated. So our index become 1. Again, compare this Bitonic point 1 with 15 and update Bitonic point as 15. Again, traverse array. Now, the next value at index 2 is 25. So Bitonic point become 25 because it is greater than 15. Again, check and update the Bitonic point with the third index value, that is 45. Then check with the next value at index 4. It is less than this 45. So no need to update this Bitonic point because here clearly the condition mentioned that if array of I is greater than Bitonic point, then Bitonic point is array I. So again traverse this array. The next element is 21. No need to update. Same with the rest of the element. We are no need to update any element because all these elements are less than this 45. So simply after traversal, we find this maximum and we have to return this maximum as a Bitonic point. So this is the brute force approach via which we can solve this problem. Let's implement this code in the code editor. Here we declare the Bitonic point value with the minimum value, that is int min. And every time we compare this Bitonic point value with the array element from index 0 till the last value and update the value of this Bitonic point. And we have to simply return this Bitonic point. So this is the brute force way by which we can solve this problem. Here we are not using any extra space. So the space complexity is big O of 1 and the time complexity to solve this problem is big O of n. We have seen the brute force approach, and there we are going to traverse the whole array, and for that, the time complexity to solve this problem is big O of n. But now the optimal approaches uses binary search, and here the time complexity to solve this problem is log of n. It is logarithmic. And here we follow the divide and conquer rule. Here we are not going to traverse the whole array. We simply find the mid value and check that the largest element is present on the right side or on the left side. If the largest element is present on the left side, then we have to simply ignore the right hand side. So that's why the time complexity here is logarithmic. To solve this problem using binary search approach, firstly we have to find this mid value. For finding this mid value, we have declared two variables. The first variable is low and the second variable is high. So low pointing to index 0 and high pointing to the last index of that array. And if we have to find the mid value, then we can simply add the low and high and divide it by 2. But here is a catch. This might got an error, that is integer overflow. Let's imagine that our array is absolutely massive and the value of the low pointer and the high pointer is a very large index. So if we add this low value with the high value, then there might be the chances that it might overflow the range of the integer or long long. So to overcome this situation, we simply use the trick of math where we don't require to add this low plus high. We can simply add low with high minus low divided by 2. Both give the same returns. Let's suppose here the low value is 0 and the high value is 8. So if we add 0 plus 8 divided by 2, we got the value 4. And if we do with the same thing here, if we add low with high minus low and then divided by 2, again got the same result. So to overcome the overflow situation, we are going to use this formula, that is mid equal to low plus high minus low divided by 2. Let's understand the pseudocode and after that we can proceed to dry run. So here we declare two variables, low and high, to find the value mid, and pick is the another variable in which we are going to store the Bitonic point value. And this while loop run whenever the value of the pointer low is less than the high, till that point this while loop is running. So if the value of array mid plus 1 is greater than the mid value, then we have to shift this low to mid plus 1. Let's suppose here the mid value is 4. And if the mid plus 1 value is greater, here it is lesser, so we have to move this high to mid. Otherwise, we have to move this low to mid plus 1. So this is the concept, and after this whole traversal, our low and high both are pointing to the Bitonic point, so we can simply return the value low or high, and we have to simply return that peak value. So this is the pseudocode for this. Now I'm going to try run of this code, and firstly we have to find the mid value and then check that the low value is lesser than the high value, then check that the value at mid is lesser or greater than the value at mid plus 1, and accordingly we have to shift the low and high. So firstly, the value of low is 0 and the value of high is 8 because the number of element here is 9, so n minus 1 value is 8, and the value of mid equal to 0 plus 8 divided by 2, that is 4. Now we have to check the value at index 4 and value at index 4 plus 1, that is mid plus 1. So value at index 5 is 21 and the value at index 4 is 42. Now array at index mid plus 1 is greater or lesser. So we can see that the array at index mid plus 1 is lesser. So we are not going to execute this condition. So we are going to execute this else condition. So it say that high equal to mid. because we can see that the next value is lesser. So definitely we are sure that the maximum element is on the left side. So we have to move this high to midpoint. Now our low is still 0 and our high become 4. Now again we have to apply the same and find the mid value. So the mid value is 0 plus 4 divided by 2, that is 2. And now again we have to check the value at index 2 and value at index 2 plus 1, that is mid plus 1. So value at index 3 is 45 and the value at index 2 is 25. So here we can see that the array of mid plus 1 value is greater than array of mid. So we have to update the low pointer to mid plus 1 because on the right hand side the maximum value is present. So we have to update this low value to mid plus 1 and here the mid value is 2. So update low to 2 plus 1, that is 3. So now our low become 3 and high become 4. Now here also the low value is lesser than high value. So low is lesser than the high. So we can execute this while condition. And now we have to check the value at index mid plus 1 and compare it with mid value. So firstly we have to calculate the mid value. So 4 plus 3 divided by 2, that is 3 point something. So we have to only consider the integer value. So the mid value is 3. Now we have to check the value at index mid, that is 3. And we have to check the value at index 3 plus 1, that is mid plus 1. So value at index 4 is 42 and the value at index 3 is 45. So array at index mid plus 1 is lesser. So we are going to execute the else condition and our high is become mid. So our mid equal to 3. So this high is updated to the value that is mid value, that is 3. So here we can see that the high and low both are pointing to same and our low equal to 3 and high become 3. So here we cannot again run this while loop because the condition here is mentioned that low is always less than the high, but here low is equal to high. So this loop terminate and now we can return the value of array low or high. Both are pointing to the same. So array at index low or at array index high, both are pointing to 45 and this is the try run of this code and now I'm going to implement this code. This is the implementation of the Bitonic point. Here we declare two variables. The first variable is low that is pointing to index 0 and the high variable that is pointing to the last index of the array. There is one more another variable that is peak variable that is used to store the Bitonic point or the highest value inside the array. Now in the previous pseudocode, you can see that I had made a mistake that I had declared the mid outside this while loop, but I have to calculate mid for every low and high in every step. That's why for every low and high, I include this mid inside the while loop, and for that, the formula is low plus high minus low divided by 2, so that it cannot exceed the range of the integer. And if the value at index mid plus 1 is greater than mid, then we have to update low to mid plus 1, otherwise we have to update high to mid. And after this successful while loop traversal, this condition becomes false. The low and high both are pointing to the same value, that is Bitonic point. So peak value can be array at low or array at high. Both are pointing to the Bitonic point. And now we have to simply return this peak value. So this is the implementation, and here the time complexity to solve this problem is big O of log n, because here it is logarithmic time complexity and divide and conquer rule. Let's compile this code. So compilation is completed here. Let's submit this. So this is all about the today lecture. In the upcoming lecture, we are going to solve more complex problem.